So yeah, so kind of so everyone, thanks for joining. I hope it's fun. It's going to be, so hopefully you're already a bit familiar of what Qwik does, because this is not going to be like an introduction topic. It's going to be a bit more of how things work and trying to get more familiar with the source code and trying to maybe make some changes at some point. So this will be, as I said before, it's like if you join Builder and you started to work at Qwik, I kind of had this meeting like a year ago with Mishko when I started to work on Qwik, and he explained me all the internals and how things work. So I think we can start how to get things set up, and if you just wanted. So maybe for everyone is familiar, but in case it's not, I'm just going to go to the repo and I'm just going to click fork. So in this case, I will just say create fork. So this way, for one's not familiar, it's just going to be a copy of the repo, so I can just work locally. I can just push changes and I can make contributions. So if I open the terminal, I'm going to just go to repos, and I'm going to copy this one over here and do git clone. So hopefully it doesn't take much. That's it. Qwik, we open here, and we start by doing yarn install. So it will do a lot of things, but some of the things we also might need is Rust. So if you haven't installed it, it will be interesting that you just go to Rust language and you start, I don't know, where it is installed probably, and you just run whatever they tell you is the recommended to install Rust. We use it in Qwik to for the optimizer, which is kind of the tooling that will do some of the transforms. That all that code is built in Rust, which we transpile to, we compile to WebAssembly to be able to execute in the browser. But it's not going to be kind of the focus of this talk. We are going to focus a little bit more in the runtime, not that much in the optimizer. So
yeah, and Manu, can I add one thing? So we've got two builds. There's a yarn build.full and just yarn build. For the most part, you probably only need to do yarn build. The full is the one that does the Rust build also. But unless you're making changes to the Rust compiler and think that, you really don't need to run that section. And it's also what we use for an actual deployment is it runs through the whole build. It does every single thing. But as just developing, really just doing the build should be good enough.
Exactly.
Which skips the Rust build and actually downloads it from NPM.
It's less slow, right?
Yes, it's less slow.
So in this case, we just install it. I'm going to do the yarn build full, which will be everything. So it will literally do all the builds of everything. So this will be kind of the first thing you need to run to make sure that at least the initial state works. So in this case, it's going to compile Qwik, compile Rust, the CLI, Qwik React. Well, Rust is going to spend here some time doing all sorts of things. And if it passes, well, then I think it's a good point to start making changes, right? So let me see if anyone has any questions, please.
Yes, I do.
Yeah.
So, sorry to, yeah. Well, I think I remember when I forked the repo and I tried working on some things for the docs, it did advise that I use the dev container, if I'm not mistaken. And then I was having issues running it. I think Glenn and I decided that was because I was using the new M1 Mac chips, and then we're looking at some stuff around that. Has that been cleared, or is that still the same thing? I just wanted to find out.
Do you use the dev container at all, Manu?
I use a dev container for so this is a very cool feature if you ever use it, is that in any repo, if you do code and you go to code spaces, you can kind of create like a virtual machine in GitHub, and it will use the dev container, right? So I kind of build it for that purpose. So I haven't tested locally. I also know that maybe main right now, it's in a weird spot with the optimizer. So do you run yarn build or yarn build full? Or it was like a completely crash? Nothing worked.
Yeah, I can't really say, but I don't think so. But probably that was the issue. I don't remember. I'm not sure I did that. It was just the docs I was working on, so I didn't really need to do too much
Yeah.
there, but I just thought to know.
I also wonder if it was like VS Code recommends, like, oh, we see you've got a Docker or whatever, you should install this. Like, that's actually not necessary, like that recommendation, because I never use the Docker anything. I just do yarn build.
I did use
Well,
Docker.
that
I'm
is-
like, I don't know how to. Yeah, okay. Thank you for that.
So while this is finishing, it's not going to take that long. Rust at the beginning is super low, but let's just explore the folder. So everything pretty much lives inside packages, like any other mono repos, and we have all the things that right now are part of the mono repo, which is Qwik, Qwik City, Qwik DOM, which is not used anymore, but at some point was kind of the fake DOM in the server to do stuff. This is probably deprecated, it's going to be removed, and Qwik React. What we are going to focus is in the Qwik folder. Then we go to source, and inside all this stuff, we will go to core. So this is where the runtime and all the things lives. And we have the optimizer will be live here. So this is where all the Rust code is, which is not going to focus right now. And yeah, so also all the commands that we execute are at the root. So all the things like yarn build, all the things we have is at the root of the project. We don't never like have commands at this level. So that's something that might be useful. By the way, this finish, everything kind of work. So any questions? Okay. So I think I was thinking today how was the most logical part to explain what it does. I think it's important to explain first what is the main transform that Qwik does, because from there, kind of the runtime tries to implement all the different aspects of it. So in Qwik, we have this playground that Adam built in a weekend. Doesn't mean it's bad. It's just like he's a very fast developer. And here we have, this is the output, nothing special, symbols. I'm going to add the typical chains here, which is on click. I'm going to do dollar. Oops, a ver. So when this happens, we start to see this thing over here. I don't know, this one. Qwik will serialize this in the HTML. So what we see here, yeah?
Can you zoom in a bit?
Yeah.
Thanks.
So what we have here is we call it QRL. And QRL is inspired by the word URL, but it kind of points to one specific symbol in this file. So all the QRLs has this shape, which is like a file name, a path, and the symbol, which will be this thing. So this is the name of the file, and this is the symbol. So in this case, I think we have some file over here. Yeah, you see app, on click 01 PAG. So that will be exactly what we see. 01 PAG, and actually the symbol has pretty much the same name. So a QRL allows us to load a file, but not only that, be able to know which function we export this function in that file. So that's one of the core principles, right?
The ID is the hash of the content?
No, that's a very good question. So these hashes are designed with the idea to be stable. It's very, very important for Qwik to have a stable, and I will talk about later. What is stable, I means that if I go here, let me just go do one thing. So I'm going to change hello and just pay attention 01 PE. So if I put Adam, right? I think I need to reload this. But it will be the same hash, and it changed the content. So the hash, it's kind of a function of where this symbol is located. So in this case will be a function of, then the file name is app.tsx, then is inside app, then is inside component, then is inside a paragraph, then is inside on click. right? And if you put all this together, we do a hash. That's how we generate these hashes, right? In development mode, we include all this information like app component, P, on click. But if I put it in production mode, wait, I don't know if the thing is, let me see. Okay, sometimes I need to do it in incognito. Otherwise I can.
See, Mano, could you,
Yeah.
I think maybe your mic is coming from the AirPods. Could you try change it to just your Mac? The volume is in and out quite a bit.
Oh, really? Okay, let me see. Better now? A bit better?
Yeah, I think so. Yep.
So I don't know right now what is going on here. I can show it in the docs in the Qwik side. I'm just going to quickly open the doc side. I'm going to check some symbol of when doing something. So the symbols otherwise will be network. Oh, so big this file.
That's great, by the way. Like debugging, this is how we learn the best, like what you do when stuff don't work.
Yeah. So it will be that, right? So you will, instead of having the whole name app, you know, imagine instead of having the whole, oops, let me just, the production mode is not working here for some reason. I don't know what, oh, wait. That makes sense. That makes sense. Okay, so if it's in production, right, it's the same hash, right? Like the previous part is only useful for development. So you more or less know where the symbols come from, right? But the important thing, really, like how we identify symbols is that. And the whole idea is that you might rebuild the app, you change stuff, but kind of these fundamental pieces of interactivity have the same symbol, which later might be useful to track. Imagine one of our ideas that you actually run a Qwik site in production using real traffic information, and you get traffic points of how these symbols are being used or are being requested by actual users when they click, when they interact. And you can take this kind of information and rebundle things and, you know, like optimize. Because actually bundling is like I'm going to take this example that has some more URLs. So if I do, it generates all these bundles. Like this bundling is a configuration thing. So I can actually change and say single, and now the same application actually emits one file, and all the symbols are in the same file.
Yeah,
So
and I was just gonna say, to like, just to clarify, like the hash ID that you see in the symbols is not about the content of it, but it's more about like where the location is. So that as you change it, as it updates, it's always, that hash is always referencing the same component, no matter how you bundle it. And then like bundling hashing is like about the content of the file, but this isn't that. It's about the, which file do you mean, no matter what you do to it.
Exactly. So more or less this clear. Any questions? Okay. So to finish the QRL stuff, in the first demo, I show a very simple one where I click, right? In this one, I will see that there is an extra thing. There is the file name, right, that we know about. There are the symbol here, and there are this little thing here, see? This 0. That's what we call the lexical scope. This demo is very complicated. I'm just going to go here and do the same that I did before, but I'm going to add console log, and I'm going to add a variable, right? So if you can imagine that if I take this variable out, okay, I'm going to put it here, wait, sorry, const variable Qwik, right? This makes sense, but notice that Qwik takes these functions and moves it out. If I take this function and I move it out, then variable doesn't exist, right? Like that code will never kind of work. Like, so it's going to be like symbol and then like hash, right? Well, it doesn't matter. But what is this variable, right? So what Qwik does to make that work is that the QRL we explained before needs to include the lexical scope, which is also what the optimizer does, kind of the transformation. And I will see here the transformation. So again, if I put here a console log and I do render in the component, we will see that the component prints render in the SSR. But if I click, only the click executes. This doesn't execute. So how is it even possible, right? How do you can run this in the client without running this code? Like this never ran. So the way to solve it is that the transformation does this. This code over here, code transform to this, right? And this variable, the first one, right? Imagine I have two. Imagine I have two. I'm going to put here foo, right? Foo bar, it doesn't change, right? But if I put the foo here, I need to change, I think. And then we have the foo here, right? And in the HTML, we will see this. Okay?
Did it just alphabetically sort that real quick? Because before it was variable then foo, and then your output is foo variable inside of that returned use the lexical scope. Is that seems like an important thing?
So it doesn't really sort it. I think it's more like an implementation detail of how we walk the EST or the resolution, and it ends up in that order.
Okay.
I'm not sure we actually sort it. I'm not, but it can do all sorts of crazy things. Like actually, the way to declare variables in JavaScript gets very tricky. I have this. We have a test in the optimizer. I'm going to show for fun because it's just funny how JavaScript can get to. Let me just show you here. So there's like a very complicated variables declaration. Yeah, like this is kind of all the ways you can declare variables. So let me see. Yeah. Yeah, like, and I think I don't think this is even the more complicated one. But yeah, like you can make something like this, right? Like, and is declare here, so it needs to track all this stuff, right? Anyways, it does its transformation, it gets that, and then in the other side you will get the HTML, and this 0 and this 1, it means that it's this obviously we have to put in the first spot the ID 0, in the second spot the ID 1, and that information is so we have to change the serialization many different times to be able to do SSR in streaming. When you do SSR in streaming, it means that what you put in the network, you cannot go back and change it, right? Because you already send it to the network. So we cannot do a serialization that later goes and add things back, right? So we serialize this 0 and 1, but kind of the relevant information happens at the end, which is this script that we add. In this context, it means this element is the element 1. So there will be the context, the 1, and it has, this is called like a context. It has the first ID is the 0, the second ID is the 1, and the 0 will be bar, and the 1 will be Qwik. So that's exactly what comes out in the other side. We will go into the serialization later. What I want to say is here is like the format of the QRL is important to get, and more or less the logic overhead. Any questions? We go. I'm going to go back to the serialization, so it's not the only part. We get here.
I have a question about the bundling, about the strategies. Is it so? It's a build time only thing, right? It cannot like bundle on the fly. Let's say a scenario where you hit a page and you get that page specifically loaded fast. And then the rest of the app, let's say it's like a B2B app that you want to load like the rest, like, like a giant chunk. Maybe you can bundle all the like rest of the pieces on the fly. I'm just like, maybe it's a silly question, but just wondering if it's a compile time or build time or can be dynamic as well.
So the problem with bundlers, all of them, Rollup, Vite, Webpack, is that they are very good at putting things together, right? If you have different files, they can put them together. But what Rollup cannot ever do is take a file and split it. So if you have even like a utils file and you have all your utils functions, Rollup will never like create two chunks. Even if for you makes totally sense it could do it, it will never do that. They can put things together, not separate it. So what Qwik Optimizer does is break it as much as possible. It doesn't put things back, right? Putting things back is what Rollup will do for you. So if there is other solutions that can kind of that bundling dynamically, that will be kind of outside the scope of the optimizer. What the optimizer does is like, it breaks it, then Rollup, Webpack, whatever, they do very well putting things together, like, which is kind of like a fancy concatenation. Like the bundling is a fancy word for concatenating things without conflict. But that's outside what the optimizer does. The optimizer,
Okay, so it's in theory it's possible, but just not in the scope of Qwik. It's just like another maybe tool or something like that Qwik can like operate with.
outside the optimizer, right? It may be not Qwik, but outside the optimizer.
Okay, thanks.
Any other question? Okay. So the next big part is that when you run any application like this, there is no any JavaScript. Like we don't load anything, but we need to load some JavaScript, right? To be able to react to the click, right? When I click, there needs to be some JavaScript that runs. So there are two processes involved. There is, I'm going to put it in development because otherwise it. Okay, so there are two things involved. There's the metadata. In this case, notice that there is no really any metadata here, right? Because there is nothing needed to serialize. But we have the URL that we described before, and we have this piece of JavaScript. This piece of JavaScript is always the same. It doesn't change. It doesn't matter if you have 1,000,000 components or one, it's always the same. And we call it the Qwik loader, right? And then there is this one. This was emitted by the optimizer by the SSR, because we need to tell the Qwik loader to listen to click events. So a Qwik loader knows that it needs to listen to click events. It can happen anywhere through the document. If I do now here, I'm going to add another, take a look at this one. If I go here and I'm going to add a new one, maybe blur. Then it will add blur too here, okay? So this is the next topic. Other lives in here at the very root. It's even outside. It lives outside because it's not bundled. It's not bundled with the rest of the core. Right? It's kind of two different projects of the runtime. The Qwik loader is a dependency-free project. I mean, here we are importing a type, but the Qwik loader cannot import things. It's a very sensitive part of the runtime. Like it needs to be very small. So all the Qwik runtime, all this code you see here is this one, is this file. And what the Qwik loader does is that it boots up. It will collect the click events that you put in window, if you put the click or blur or anything. And when the document is ready, which is something that happens here, like then what it's going to do is going to pretty much broadcast a Qwik init event, and it's going to be listening to these events. It's going to set up the event listeners, all the stuff, and then the event listeners will go through this, which is all event listeners that will in the capture phase. The capture phase of the event listeners is before going down and bubbling up. So all the events that happen will be captured. It's like a global listener of events across the whole document. Any questions?
Yeah. So what if you go from like one route to the next route that has different handlers? Are you guys collecting it through the whole app, like all the files or all the events that I could possibly do, and then it puts it in there, and so you don't have to like swap them in and out per page?
What do you mean, like when you actually full reload the page, or?
No. When you like using the Qwik City router, when you go from one route to the next, and say like there's an on click on the first page and an on blur on the second page, are both on click and on blur going to be present on the first SSR load of the app inside of that? Do you collect all the events across the app?
No, we
Okay.
collect all the visibles in the SSR. So we SSR, and we will only be listening to those.
Okay, so there's a second like hydration or some kind of thing.
No, when the runtime happens, when there is a re-rendering, right? The runtime, the rendering also if there is a new events, it will also do window quick events, right? And it will communicate, because this push, it behaves like an array, but when the quick loader is there, it becomes like a API to tell the quick loader, now start listening to this other event. Okay. So, but it will be a rendering, like something renders, something changes in the page, and now the quick loader might be listening to more things.
Okay, cool, thanks.
The logic is kind of simple. So process document events. Here we pretty much, for every event that is being pushed, a click, a blur, a scroll, we create an event listener at the document, we create an event listener in the window. And basically for the window case, we broadcast, because in Qwik it's possible to get document events from any element. But otherwise, we will kind of simulate a bubbling. So we just go to the target of the event, which is where the element was originated, and kind of walk it up. And the execution is called dispatch, right? And dispatch is it has the little logic to be able to parse the QRL, know where it needs to do an import, get the file, get the symbol, and execute it, right? That's how it works. Any questions? Okay. So at this point, it's important to say two things. The containers, all the applications are containers. So it's this thing over here, right? So a container is literally this thing that contains the whole application, right? And at a given moment is pause, and then happens, it resumes, right? So the server generates the container and does all that stuff, and then it sets as pause. So the container is also how all these files are being resolved. So in order to load this file, it actually needs to go to the Qbase of the container. So the container is telling you all these things live in this path, because otherwise it's not possible to load this file, right? It will be relative to what, right? It's always relative to the Qbase, which is injected at the core. The very interesting thing is that because every container knows how to load the things it contains, you can have multiple containers in the same page. And there's a very cool demo. I have it, I think, here, which was built by, I don't know, we are going to have a lot of time, to be honest. Maybe we go faster when we get to the topic. So let me see. This is kind of cool. Oops. npm run start. It's going to show you what can do without getting also too much detail. We have the containers demo. And this app, if we see here, it's a Qwik City app, right? But it's actually taking parts of HTML from this different worker in Cloudflare, which only renders the header and it's interactive by itself. So it's a container here. Notice that the container is not even the HTML. The container in this case is just a header. And it's just interactive. Then there is a body, which even has a streaming, HTML streaming. Again, this is interesting because it's literally I disabled JavaScript. It's literally a HTML streaming. So there is no JavaScript being executed to do this thing. I'm going to enable it back. I always forget to enable back, and then I'm like, why anything is working? I was once making a demo and I disabled JavaScript, and then it was like, what is going on? So in this demo, right, it's a Qwik app that has many Qwik apps inside. So the parent app is pause, and it has a Qbase, and then the other one.
It's a lie of the micro frontend.
Yes.
Multiple application in a one container application.
Exactly. That's kind of what it can do. So for example, you can see here that this app is Qwik City, right? So it's using beta, but this was a long time built by the Cloudflare team, and it's using a different version, right? And this Qbase is relative, but because I have to put a reverse proxy for course reasons, but it will be like it can be like a different server, you know, deprecated by someone else. And it's all here. And the very interesting thing about this is that no JavaScript was executed. Like in other micro frontend, you have the problem of now you have React 5 times. Here, not really, right? So if I never interact with the header, it's fine. But what I want to show you here is that notice that the parent container is going to be paused, but as I interact with this one, which is this one, it gets resumed. So as I interact with it, this local container got resumed, and the rest of the application, the rest of the little apps are still, you know, sleeping, right? So containers are important because all the in Qwik is very important to serialize things, right? And all the serialization happens within this container. So every time you go to the core, you will see at some point that everything needs a context. So that's where I'm going to go next. There is a invocation context. Things need to know kind of where they execute to be attached to some container or to something like this, right? Any questions?
Yeah, I have a question. Sorry, I feel like I'm asking too many questions, but
No.
I want to give other chances. So just tell me to shut up and ask a question.
No, of course.
How do containers communicate with each other? Do they share like use context or something like that? How the messaging happen?
So what we think right now, we don't have a built-in way to communicate because we think that containers should communicate by message passing. You know, that's kind of our strategy. So it's not going to be like they share memory, because I think that's it's going to be tricky and it can have a lot of problems.
Yep.
But memory passing, and memory passing is events. And how events will work? Well, because the moment one container emits a custom event, there can be other code that listens to that event. And the Qwik loader will wake it up, that container, right? So now containers can wake up other containers just through using the same mechanism, the same events, right? Events can still be the way of how containers can wake up other containers. And if a container doesn't have any events, then it's never wake up, right? It's just dead HTML, basically. So it's important here. The Qwik loader is still one, right? There's not like 5 Qwik loaders. All the containers use the same Qwik loader. That's kind of important. All of them, they have their own custom runtime, all rendering different versions, but the Qwik loader is the same. That's why also the Qwik loader is like a tricky part, right? You cannot, they have to be like a very stable in the kind of things it does. You cannot like breaking changes in the Qwik loader is a big deal because it will just break.
Is it versioned? Like in terms of like
it's very simple in a way, right? That's why we want to keep it simple, but because the more logic we put there, the more chances we have of how to introduce breaking changes. So far we haven't been breaking changes for months in there, so not really. But if we save the 1.0, we will have to, right? Any other questions? So the next thing is the invocation context, right? And I think this is relevant to how the hell, let me see, how the hell this, let me see, I'm going to put a variable here, I need to put a variable. So const variable, oops. Like, let's see. I'm going to remove, the click is distracting me. What is going on? So this use lexical scope. How does it know? Like how use lexical scope now know that? Because use lexical scope is in all the, like, how does it know this on this lexical scope that is different from this other lexical scope, right? Like they are on click. What I'm doing wrong? I mean, okay, here. Like these two lexical scope, they are the same, right? But they return. And they might return different things, right? If I put bar and put something else, I put here, right? One is going to return var, the other one is going to return variable, but they are the same, use lexical scope, right? So how this works is what we call the invocation context. So every time one of these hooks is executed through a system that we have to have like a synchronous execution context. That's why, for example, the rendering of Qwik can be async, but the rendering function needs to be synchronous. And I'm going to show you that. So invoke. So every time we, no, it's here. Wait, yeah, this is Qwik. Okay. So invoke. This is a trick that is used by a lot of frameworks, like Solid is how they track reactivity that happens in a specific place, or things like that. It's about the concept of putting some global variable. So in this case, it's context. Let me see. It's literally a global variable that is going to be set before the execution and restore after the execution, right? So this has a problem. If there are async things happening here, it will not catch it, right? Like, the thing is that it might seem like it's unsafe, but at the same time it's not, because it's synchronous, right? The flipping, like we put it and then we restore it in the synchronous here, right? And it's catch with a try catch, so we always make sure that we restore the previous one. So it's not possible that it happened that suddenly you get something else. This invocation context is key because that's how we can track, we can attach things to this invocation context and say, this invocation context is part of this QRL that has these variables, that has this lexical scope. And that's how use lexical scope can work. So lexical scope is a very tricky one compared to the rest, because use lexical scope is the only hook that can run outside the rendering. All the other ones, like use store, all the rest happen inside the rendering function. Use lexical scope can be in anywhere, right? Can happen even before the application wake up. So when it wake up, it does this thing, which is resume if needed. Notice that this application, when it runs here, this application was not resumed. All these variables were in the HTML only, right? All these things were here, but we have to wake up. We have to create the objects. We have to build the structure. It can be, it can be complicated things like a nested object, like foo, bar, like, foo this, and then recursive, undefined, and then you do actually variable recursive equal variable, right? So the serialization is not just JSON, because JSON will end up in, they cannot render like serialized cyclic things, right? So in this, how do you serialize variable in this case, right? Because variable is pointed to itself, So that's how Qwik serialized it. And there is a process of resuming, which is what kind of happens in use lexical scope. So every time you have an event, there is a chance the application needs to wake up. And that's what happens in resume if needed, which is going to check if the container is paused. If the container is paused, then it will run the resume container. And it takes the container element and it does a bunch of things. In between them, like going and taking this big object and parsing and generating the things. That makes sense?
So this is just like a mini hydration for just that container, right?
It's a hydration of the data, right?
Sorry, can I jump in here? I don't like the word hydration
I know. I triggered the Misko.
because technically it's not hydration, right?
What is the difference? What is I know that it's not like eagerly doing it from the start, but when you're disappear, like this JSON disappears once it's resumed, right? So because it becomes this object on the app, right? Instead of this like serialized data, right?
Yeah, I think the way to think about it is that hydration is building up the event handlers eagerly. Resumability, first of all, it builds them up eagerly and builds all of them, right? Whereas resumability is doing it only after the event is fired, and it's only building the event handler for that specific event. And I think that's the huge difference over there, right? Like a hydration just implies that like you go eagerly and be like, oh, I need an event handler if you possibly click here, and I need an event handler if you possibly move mouse over here, and so on and so forth. And all that stuff is eager. And that's what makes hydration slow. The resumability key point here is that you don't even know what the event handler is until the event actually happens. And then you only resume that specific event handler.
So it just takes the serialized data and turns it into like a map or an object in JavaScript, right? And that's it. It doesn't like run all the things and attach all the events and stuff like that.
I will say that resuming is synchronous without having, and is upper, and the complexity is limit, right? Like it's only that. Like it's not like resume. Hydration is that you might have to download code and run things. You don't even know how much time the hydration can take, because sometimes the hydration might have a fucking huge processing of data that takes, I don't know, you don't know, right? This is like, well, no, it's like taking this data. It will be a function of the amount of information, but not a function of processing. It's actually a synchronous thing.
I think that's a good
point. Yeah.
That hydration is right. Hydration requires the application code to be present. Like you cannot hydrate without application code present, right? Whereas you can resume without application code. Like the framework can resume the system with zero knowledge about what the application actually is. Whereas the opposite isn't true. Like hydration requires that all of the code is present because you're required to create all of the closures and so on.
That's a great point. That was a confusion point for me, and now I know how to explain it better. So thank you for that.
Yeah, I think a lot of people get excited and would get like annoyed saying like we're making up a new term, or that like, oh, it's just a hydration in disguise or whatever. But like, I think these points are significantly different. That like, I don't think it's the same thing at all. The end effect is the same, right? You have an application that interacts, but the process is very, very different.
Exactly. Any other questions? But that was a very good question. So I will say that invocation context in this case is used for lexical scope, but it's used for more things. That's how we can keep subscriptions, right? When we execute the rendering function, we also give to this QRL, right? The QRL of the rendering at the end of the day is this one, right? We execute this QRL, this symbol, which is this one over here, right? With a specific context. This invocation context is what, when there are reads to stores and things, we can keep these subscriptions and trigger re-rendering, which is something maybe we don't have much time. But yeah, so I think next topic, if I'm want to look, is the rendering. So in Qwik, there are fundamentally two renders, which are very independent. The DOM render and the SSR render, right? So the DOM render is actually very, very special. It has a lot of cool stuff. The SSR render is very optimized for putting strings together, right? It literally, as it renders, as it walks the tree, the GSX tree, it just puts strings together and push it to the network as soon as possible, right? So this render achieves things that are very cool, like streaming, right? We can support streaming because the render can just push stuff to the network as it goes. And you can have promises in the GSX, and it's fine. It will keep pushing them away, and it will keep pushing stuff to the network. So the implementation of the render is here. It's in renders, and you have the DOM and SSR. It's just one file. It's big and it's kind of messy, but basically I'm going to start from scratch. It's render SSR. It goes to render root, and then you have this kind of render node, right? And it will take a GSX node and render it, right? So what render does at the beginning is that it checks if the GSX is a div or is something special, because we have some special nodes, which is maybe the ones used for components and not. If it's div tag, it literally, as you can see, it literally does a concatenation. So in here, it's literally doing the p and then render attributes and just goes, right? I mean, it's we can really get much into the details, but here it's trying to render the class. Then it tries to put the listeners, for example, right? And in order to render the listeners, we have to serialize this QRL that we saw before in the so this is literally what it's doing. And all sorts of things, right? And then it keeps walking from the children as a recursive algorithm that just goes, and it has the context of the stream, and this is important. So a stream, all this kind of walking of GSX, it's not like it walks and at the end it returns something, but as it walks, it has a context of the stream writer, and the stream writer is just that. It is an object with a write function. So as it goes, you can start pushing things to the stream before even finishing, right? That's how kind of the streaming of it works. The DOM render, though, is more complicated and more at the same time is more like obvious. It's just interacting with the DOM. But one of the fundamental things here is that when we run the tree in the DOM render, we cannot actually modify the DOM. So what we actually do is queue operations. So if you see in some of the apps, for example, let's see, I'm going to open one of the examples here. No, I think I can actually open this one over here. Wait. So you will see sometimes in your applications, when you do some changes, this kind of logs where it says rendering stats. Maybe you have seen it from your application, and you see there is operation. See that? So in this case, is when I change the increment, in all the stats, there is only one operation, which is set property of the text data 10. So it's changing the text. That's the operation it does, right? It can be more complicated things. I don't know, maybe the clock. So the clock as it runs is actually doing, let's see, 3 operations. It's changing actually the style of the 3 little things. That's what it's doing. This is important because we need to queue all these operations, because the render in Qwik compares with the rest of the renders of the different frameworks is async. We cannot push things to the DOM, because as we walk, we push things to the DOM, you will see flickering things. As things load, you will see how this renders and then it's kind of there, and then the rest things, you know, like it will be like kind of fucked up, right? So the quick render needs to walk, collect all these DOM operations, and when it finishes, it creates a request animation frame, and all of them are executed synchronous. So you have all this async render, but visually for the user, it behaves like a fully synchronous application, like in React. You don't have like strange behavior. And this happens, let me see. So this happens when we have, for example, let me just find one example. We don't have to go into all of them because it will be a lot. The visitor. So in the visitor, we have set update properties, right? For example. So this is done with the patch v node. So it's when we are finding a difference here. This is a typical v node implementation, but we are kind of checking the things. So update properties, it does like a diffing, like trying to see if the value is different or not, blah, blah, blah. At some point we do set attribute, right? We know for sure that we have to change the DOM, right? So set attribute is not really setting the attribute, right? It's appending kind of like a task to this array of operation. And that's the other point of here is the render context. As things render, we have a kind of a render object where we collect things. We know things that are happening during this render. When we finish walking it, so that's another thing. When there are mutations, there's some state that changes. These mutations can actually trigger updates across the tree. So maybe some state changes, and there's 3 different components that need to re-render, right? So that's what happens here. We wait one, when we have this operation, we have the rendering queue, and it's actually interesting how we have to sort the nodes, because we have to walk these nodes in a deep first. So we have to first note, because we cannot render first a component that might be the children, because then we will have a problem, right? So we imagine like some state changes, and you need to actually the parent and the children are roots of the rendering of the change. We actually need to render in a specific order, because if we first render the children and then we render the parent, and the parent changes the props of the children, we have to render the children again. So it will be like a bit weird. And the very interesting thing is that we use a very cool API, which is compare document position, which I learned about while building Qwik. It's a very interesting API, but it basically, you give it 2 nodes and it will tell you how these 2 nodes are relative to each other. So you might know immediately that, oh, this children is it will be, you know, like it's it will be like a descendant, or it's like in a pre-order depth, it will be here or there. So it's what we use to sort it. And then we execute them, right? And that's here. We are rendering all the components, seriously, right? And then when we finish, we have operations, and we have the request animation frame, and we execute the context. And basically the execution is literally going through all the operations and do it, right? In a while loop. That's kind of how the thing works. So these operations might be just 2 things, right? Like change this text node or add this attribute. That might be the only thing that it does. Any questions? Okay, so we are already out of time, but I can keep a bit to finish address reactivity and the pausing. What do you, is okay? Good? No?
Go for
it. Okay, so I think the last part is reactivity. I mentioned that reactivity works by having an invocation context to kind of set where these things is, where this QRL execution is happening. But where exactly this is being read, it happens in read, write, and just know the names of the classes. So that's going to show the relevant thing here. So we kind of use proxies. So a proxy is this kind of object that allows you to capture. I don't know if anyone here, there's anyone here that doesn't know what a ES proxy is? Maybe I can explain it more. So everyone knows what it is. It's this API. All good? Yeah. So the way that we leverage this API is by creating every time you do something like use store, and you pass here just a normal object like foo string, right? What we get here is a proxy in the other side, right? And this proxy, the implementation is this one, a read-write proxy handler, right? So the target will be the object, and this is the implementation of the proxy. And the proxy, at the end of the day, this is just implementation detail that is not relevant, is that it uses the API, try to get the invocation context, and try to guess what this does. It literally tries to get this one, right? It just gives you that global variable. It does a lot of other, a little trick here. If this will came from the Qwik loader, because that will be a bit different, but fundamentally, like 90% of the time, it's just trying to get you this variable, right? That's the only thing it does. And it gets the subscriber. Is one of the properties of the invocation context. So in the invocation context, I mentioned it before, it has a bunch of things. It has the URL, sequences, host. Sometimes it's used one thing or another. The subscriber is what is relevant. So when this curl executes, inside this function, if you actually execute the proxy and the context, invocation context is giving you a subscriber, it means that this code path over here is going to be taken. The subscriber is going to be something, probably an element, and is going to use, is going to add a subscription. The whole subscription system is part of a serialization thing. It's basically at the end of the day, it's like a map. It's saying, look, this object has an array of things that depend on it, right? And then it's a bit more complicated because it needs to be able to clean itself efficiently, because every time we render, we have to clean the previous subscriptions. But that's kind of implementation detail. At the end of the day, every time you get, if there is this get is executed in this invocation context configured properly, then you get that, right? And there is only one place where this happens, which is, you can guess, is when we execute a component, right? The function that executes a component is the one that sets the host element has the subscriber. So then when we render, there's a get. That get of that object will be a path related to that host element. I'm making sense of what I'm saying? Does it make sense or not?
That's why you get an error when you try to use store outside of a component.
The creation of it, right? You mean?
Yep.
Not really, because it's a use method. So use method, we are saying it will crash even before that, right? When you even create the thing. But it's a good question, right? Use methods. Let me see. Use store, right? Why do we need use method, and why the use method have to be called inside a component is because the invocation context. So this the use store uses the use sequential scope, which is very implementation. It is not very important, but this one does use invocation context, right? And gets that, and gets the invocation context. So yes, right, you can only execute use methods because they are executed inside this invocation context. That's the reason, right? Otherwise, the store will not have like a specific access to things that it need, especially for serialization. Does that make sense? So that's the reason.
Yep, thanks.
Any other question? I think we are close to the end.
I have a question. I know we don't have time. Just about the track function for use the watch and stuff.
Yeah, that's a good. So track, I think it's tracker. No, wait. I'm not in the right place. Wait. I always. Oh, by the way, my way to navigate the repo is usually searching for the word I know. Like sometimes I don't even know where things are. I just search for a specific word I know. So in use watch, we create a track, right? This is the track function, which later we put in the resource context. So it's the same for watch. I think this is the one for watch. So this is the option, right? We have the cleanup and track. This is what, when you do use watch and then you do track, right? It will be this one over here. So this track is doing a escape hatch, but basically it's getting directly the manager. So I don't know if you remember that in the repo, it does something like this. Right? If it has a subscription, it gets the manager. The manager is the subscription manager. It's like a helper object that keeps track the subscription of this element, right? It's just like I call it manager. Probably it's a bad name. Naming things is very it's tricky. But it just get the manager is this, again, subscription manager of this object. I get it and I do the subscription. In the case of the track, it just goes straight to the manager. Like it just uses this API to get the manager. But it uses the same API, right? Like one uses context. Use watch doesn't use context. You know why? Because the reason for this is that we were use watch allows to have a wait, and we were worried that people will do this, a wait fetch, right? And then they will be a store.value, and then they will be surprised that the value is not being tracked, because this await lose the invocation context. Does it make sense?
Because
so that's why the API was like, let's be more explicit and allow them to do this stuff. So that's why you can do value, but you can use track anywhere, right? You can use track even after the await, because track doesn't use the invocation context to have subscription. So yeah, it's kind of a trade-off of allowing to have promises or like awaits inside use watch, which we think is important. That's why there is I think we took the trade-off of saying, look, just be explicit about what you want to track. And I think also in the long term, even Ryan mentioned that sometimes when the subscription is automatic, there's too many things that you subscribe that you actually don't want to subscribe. Like maybe you are reading one value to check something, but you actually don't want to rerun it every single time that changes. So I think that's the API decision about why track and why the subscription is explicit in watch. I think it's a good decision. At the same time, it also solves a technical problem of having awaits here that will lose the invocation context, right? That's the reason. Good.
Yeah, thanks.
Last part, which is pausing. So paused container, I think it's called. No, pause from context. So I'm going to show how the rendering happens. When we render, this is the render to stream. the stream API, right? It does a bunch of things, not relevant. We have, this is kind of like a logic to, we can like do like a, not to stream all the time, but we can like kind of like put things together. Not very important. The magic happens here, right? We call render SSR, which is the function we saw before in the rendering folder. This one over here. So it does all the rendering, and at the end, before close is kind of this hook to say, before you put the last closing tag, because we are streaming, right? Before you close the closing tag, let's do the serialization, let's do everything, right? And it does a queue is this is the function that does everything, which is pause from context. Context are any element, because in SSR there is no elements, right? But any element has this kind of context, and this context is where the listeners it has, if it's a component, you know, metadata about the element itself. Pause from containers is a very tricky function, and that most of the time should never have to be changed. And the idea is that developers have to add serializers. And serializer is a much nicer API to inject functionality inside the serializer, which is, I can implement custom serializers for different things. So for example, Qwik supports serialization of URLs. And the way to achieve that is we give a test function. So we say is instance of URL, a function that serializes it, in this case, object href, right? I think that's enough to serialize a URL. And then to get it back, right? So when you use this, then you append it to this array of serializers, and automatically you get a new class implemented in the serialization. So now if there's a new URL or something there that needs to be serialized, the application is going to be able to convert it to a string, and then in the client side, it's going to be able to convert it back to a URL class, right? You can, now I'm implementing signals, right? So the signal will be very similar to something like this. Signal serializer, signal. It's going to be like a signal, basically, right? The prepare is going to be something like, the signal is kind of like a reference to something. So it will, anyways, that will be how you implement it, right? And what all this logic, this very complicated logic does is to walk the tree from the listeners. That's why an application that doesn't have listeners doesn't serialize anything. So the very interesting thing about this algorithm is that it's not a function of the amount of components that you have in the page. It's a function of the amount of listeners. Because what we do is that we walk the tree from the listeners. So in this case, I'm going to show you for a simple case, which is the playground. Let me see. Hello world is too simple. So this one, right? I'm going to open here. So in the symbols, we see that we have one event listener, which is this onClick. Okay? Over here. So the algorithm only has one, the serialization only has one route to walk with, to walk from. This entry point, this listener captures a store, right? And how do we know that? Well, because it's part of the lexical scope. It's kind of the QRL object. We know this thing has a store. So we serialize the store, right? This thing needs a store. Maybe I put a text here, foo Invoke bar, right? So now we know, I'm going to put this, right? So we know that this click needs two things, a store and a foo variable. So we will serialize both. So we put two of them. So imagine if I this store, I'm calling it here, and it's serializing it in all this information, right? But if I don't use it, then it's not serialized. See that? So just because the event listen is using it, it shows up here. The count, see, the count is here. Oh no, not the count. Where is, yeah, count. Yeah, the count is here, right? The moment I change that, is removed because it doesn't need it. Nothing in this whole page needs it. So we serialize the store, but we know more information. We know that the store has subscriptions because during rendering, notice that we do a get here. See that? The store.get. This store.get will go through the proxy and append a subscription to that store, right? So now we start from the click listener. We get the store. Now the store, we see, oh, we have a subscriber, which is this thing, right? But not only that, I could even have more stores, right? Like use store. And now, because the subscription points to the element, now we have to serialize the whole element, the props of the element. For example, the element might have some props that the parent pass. In Qwik, we need to be able to run this component without the parent. So we need to serialize the props too. That's what we call leaking the element, or I call leaking the element. It's like when something points to the element, we have to leak the whole element, right? The whole element needs to have all the state to run, right? The very interesting, I'm going to show a very cool demo here, and it's going to be the last one. I'm going to make two components to prove this. So I'm going to put child, I'm going to put props, and I'm going to put this count over here. I'm going to remove it. It's going to be here in this other component, okay? So store props count. I'm just going to be here any, so we can, no, any, and for now, before signals, I'm going to do this, okay? So I'm going to pass child, I'm going to put store, and I'm going to pass the store, okay? So this store. And this one other, I'm going to put here, oh no, value. Okay, imagine it's like 1 megabyte of information, right? And I'm going to render this in here. df value. Okay, let's go to option development. That makes sense? For now, it's making things sense? Okay. Why is... I don't know why it's...
I love how you point to this weird word and ask if it makes sense.
So notice one thing here. So, damn it. It happened the same. Okay, no, I'm good. No. I lost it. Why? This gesture to go back and then you are... man. Man, oh no, okay, see. It was almost there. Okay, let me just try to do it fast again.
No pressure, Mano, no pressure. Really.
Props, remove it. I'm going to do another one here. I'm going to put value and something long so we can see it. Store foo span foo value. Okay, so if I interact with it, right now, notice what is happening now. This component, this click, is capturing a store. No, I'm going to remove this one. Wait. I didn't finish the demo. Child store state. No, store. It's called store. I'm going to put here any. Okay. So notice here that this store is capturing the store, but this store, the subscriptions of this store is not app. App doesn't read store. See that? Like what child reads store. So if we see now what happened to serialize, we will see that in the serialized code, which is this, there is nothing like this, right? It never had to be serialized. All this foo state, because there is no any reactivity, there is not any interaction that can lead to that component to re-render. So this component is dead. Right? This component is not even like Qwik in browser doesn't even know that this is a component. It's like HTML there. No, nothing, right? And the thing happened here. We put it in a script, and then it will connect what I said at the beginning of the click, and they use lexical scope and resuming, and that's it. I don't know.
Because you don't have a mutation, so that just renders once and that's it. And if you had a mutation, it would add then, like it would become this like variable and stuff.
We have removed the mutation API. Mutable. You mean mutable, or what do you mean?
No, I mean that you don't have any writes. You only read it once, and that's why it becomes just this HTML, like rendered as HTML.
Yeah, because it doesn't read it, right? At all. Like it never. This component doesn't need it. But in the moment I need it, right? In the moment I put this line here, then it's not store. Then yeah, it needs to be here, right?
Yep.
Because that component can happen. But the most interesting part about this is that the same way that we know which components can happen, that's the information we use later in the prefetching, right? So that's why you don't need to click to download the code. Like we know which code can be clicked. And not only that, we know that when you click, it's going to cause the re-rendering of that component. So we know that, imagine you have a button in the footer that when you click, modifies something in the header. Right? The prefetching will know that the only two things to prefetch is the click handler in the footer and the rendering in the header. That's the two things you need to prefetch, right? And not even the rendering of the footer. Maybe the footer is completely static. So we only need to get the click handler. I think that's it. If there are more questions, of course there's a lot of questions, but anyone just in Discord, or if you guys want to have another one which is more specific about one part, we can do it too. Or if you feel like you want to learn more about the render and you maybe want to do some contributions, then we can chat and we can have another one about that specific thing. It's hard to fit all of this in 1 hour and a half.
It may be a bit dense, but when you copied and put that on line 10 on app.tsx, you put that in, it then serialized the foo store. And I'm trying to figure out, like, how are they connected? Why did it have to put foo into your Qwik JSON at that point?
Yes, because so yeah, you will say that it doesn't really have to, right?
Mm-hmm.
It didn't really change, but that could be an optimization, right? We could have some sort of way that the store was never mutated, but it could be that something actually changed it. So we are not serializing this value. We are serializing the actual value of the store, which turns out to be the initial value. But it could be that it's not, right? So we need to serialize it. This code here is kind of the initial value, right? So is different. It's the actual value of the store, but it's a good. It could be an optimization. We could kind of have a flag that says we never mutated the store. That's actually a very good idea. We never mutated the store. So the kind of this object will have some sort of flag. So later in the serialization, we can just put an undefined. And later when this code runs, it will be like, oh, actually you need to take it, like put it from the initial value. I cannot just assume that yeah, that could be something to do. I think
Good idea. Good idea, Cody.
Do it.
Your first contribution. No.
Sure.
Oh, if you have a time, I would love to show a very quick demo of signals, because it's very, very cool what it can do. So
Yes, please.
I think you just you just cloned that repo and you probably didn't include your branches, and that's your local.
yeah, that's a good one. So check out feed signals. Yeah. Okay. So yarn build. I promise it's going to be cool. So if you wait 1 minute, I promise you're going to be like, what?
By the way, how close are you to finish this?
Maybe 1 week. The
Wow.
problem is that the problem of the signal, you will see that it's not about the API, it's about the rest of the things.
It's like a low level thing that you can use everywhere else.
Yeah, and it applies to stores too. One of the problems that we have right now is that is this problem. If you see how here I pass the store instead of the value, because otherwise the parent will render, right? That's kind of weird. Like people don't pass a store, like you pass the values, right? That's kind of like how you write code. The problem is that you will have the React problem, which is like the components needs to re-render to pass data, which is kind of dumb because you're just want to pass data, you are re-rendering. So the part of the signals is to allow to write code more idiomatically, even if it's signals or stores or whatever. So let me show you, because I think it should be already here. So oops, I clicked something here and now okay. So yarn, sorry.
I think that's your older code, not the one where you were building.
Okay, so let me just close this one then. I'm going to close everything here. Okay, this is fine. Oh, no, that one, no, serve. Okay, hopefully it works. It worked last time I tried. So signals. Okay. So bear with me. This is going to blow your mind. So I just want you to pay close attention about the app. So this is the app, very simple app. Okay, so we have a component and they use signal. Okay, so signal is going to be the same of a single value store. So this is the same as doing, or pretty much the same. That's doing store value 0. So in a way, we are not introducing a completely new concept, right? It's going to be object based. So but we think like we are allowed to have even more fine-grained things, because you're not passing whole stores, but things that, and the capture of it, you're not capturing the whole store, but you're capturing that value, right? Which is, I think, is going to lead to better patterns. So I think it's more about the patterns developers write than the API.
Could it be recursive as well? Like, and then the object you pass to the signal could become the store, basically?
Maybe. I am very fan of that. But so let's see. So we have a console log parent and count value, right? There's nothing weird, nothing fancy. So the children component has a props, and one of the props is count. And I was thinking a lot about this. Developers don't want to say my prop is a signal. No, my prop is a number, like a string, like all these little, it's weird things. Like it's kind of like workarounds about the fundamental problem of my component needs a string, a number, and something else, right? An array. It doesn't need a signal. Because I could even say that maybe the user will just pass me a number, right? It doesn't might have to be dynamic. So you as a developer of the component doesn't have to make assumptions about how they are going to use your component. Sometimes maybe pass a signal, sometimes maybe a number.
Yeah, like Storybook would be a great example. You're just passing
Yeah,
a 0 rather than a signal. Yeah.
exactly. So here we are doing the same. So nothing weird. That's what developers will write. If they come from React, they will just write that. Because that's the obvious thing, if you think about it. We know that this might be inefficient, blah, 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 but this is the obvious thing. In the child component, the same. We will pass props and count is a number. Everything makes sense here? Okay, so bear with me here. I'm going to put the parent and then child. And I'm going to execute again. Okay. So if I refresh, we get parent and child. That makes sense, right? It is secured in the server. Okay. What do you think is going to happen now when I click? What is going to print?
Oh, you're probably hoping just child.
Okay, let's click.
Or nothing. Oh,
So-
shit, it's not even re-rendering it. Okay.
So Qwik in this case will be able to not download any of those components. Nothing. It doesn't download. All this code could be removed. Never sees the.
Can you repeat again the?
So what's updating it then?
So what is actually happening is that, you remember how I said that a store has subscribers, right? And the subscribers can be the element or a watch, right? Like we need to, whenever this changes, you need to re-render that or re-execute that. But what we can do actually is that the subscriber can be much fine grained. It can be literally that text node is the subscriber. So in this case, we can do that because the thing was passed around without modifications. I didn't do things like +1. In that case, yes, I will have to re-render this component for now. But we see that in most of the times, we can get like 90% of the things straight to a DOM element, straight to an attribute, right? Like you could even have something like class, and then like the thing which is like a Boolean or something, right? That kind of things we will be able to update that one. And some of the interesting things about this is that the rendering of this, I have 20,000 components, 20,000 here. Like a lot, right? Like the client side rendering of this, the first one is going to be, it's going to be a bit expensive because of the resuming is a bit more expensive because it's like just the DOM is expensive, but just when you are like executing the app, it's even hard to see which one it is because the action is yeah, maybe this one. Click. So it's maybe this one. Yeah, probably. Yeah, set value. So it's this operation, right? Because we don't have to do any more work. Like in fact, Qwik didn't have to download the components. And the interesting thing is that if you actually go to the JSON, This is it. There is no even like QRL. Remember, like when we render things that require like a component to re-render, then you end up with these things, with like these ones, right? Like you need to serialize the rendering, like the QRL itself here, because it needs to get that to re-render the component and the whole state of the component, right? Like notice that, yeah, it only serialized the state for the count. It didn't even serialize the props. So the component might have props. So that's an experiment. For example, I can say text, right? And I can say, right? So I say text string, right? And I can maybe put the put that. So I need to, this doesn't have library loading, I have to do it manually. So if I refresh this in the state, right, there is, that doesn't have to be there. You don't have to serialize the props or anything, right? Because we don't, that components are static.
Mm-hmm.
So that's the feature of signals in Qwik. And it will not be a breaking change. So it will be, you will write components like you do.
It's amazing.
This sounds to me like a svelte interpreter.
Kind of, right?
Because it's like avoiding everything and going straight to the place, like a very granular. Yeah, it's incredible.
I think like they go a lot longer than that, but I don't think they have the trade-off of they need to serialize the stuff, right? They can keep like a lot of this subscription in JavaScript and it's fine. But we also have the trade-off of we need to be able to serialize this, right? And I have a hard time thinking. So we are not. I'm trying to think where we are right now, and I think we are trying to get there in step by step, like more and more optimized in the simple things we need to re-render. But we also have the constraints of things need to be serializable, and you know, in Solid, for example, they can do a lot of crazy tricks, but they will have a hard time moving this to a resumable approach because you need to restore it. So that's the trade-off, and we think that this API will have a big impact. But yeah, like I can imagine that Solid can even do, for example, here, like they can do even this, right? If you put this in Solid, they will still handle it, and we will be like, we can't right now. Doesn't mean that we will never be able to, but right now we're like, we can't do that crazy trick. Yeah. So.
Any trick?
Huh?
Any tricks you do complicate serialization, I guess. So it's like a trade-off as well. Like any things you try to put like that +10 will make the serialization bigger or something like that.
So the thing here is that here we can serialize that the prop is going to be the. I can show you the transform. Starters, packages, optimizer, snapshot. So we have one snapshot that is this. Wait. Yeah, this one. Okay, so this is the input code. Okay. So static. The thing is show 2 levels, right? This is like 2 levels nested. This is just passing a variable, and this one is like a data processing, right? That's kind of like the test. And then here we are consuming the props, right? Here we are putting the props in an attribute, and here we are putting the props in the children, right? So the transform is tricky, you will see. So it's a GSX, but notice that, wait. No, this is the one, this is a good one. So unchange, the count, okay, is converted to a getter. So there is not really execution of it. We are postposing the execution, right? But the problem with Solid is that Solid can do this, and Solid is gone. Solid can actually do this for everything, right? They can be, they can do the same for here, right? No problem, right? That's what Solid does. Solid will make headers for all this stuff. That's what Solid, the transformation of Solid does, right? And it's fine. But how do you serialize the getter? You cannot serialize any kind of getter, right? I mean, if you have an idea of how, but I can't think of how you serialize a getter. Like you will have to put the whole implementation of the getter in the serialization. Then you cannot lose the point.
You have to eval it. You'd like stringify it and then eval it.
But then what if this? But not really, because this also has lexical scope, right? It's capturing a variable.
Turn around.
Does it make sense?
Yeah, that's really nice.
Tony,
Tony,
Go what?
we can hear you.
No.
Yes.
yep.
This. Sticker.
Tony, I think he muted the wrong thing.
So the trick here is that we emit this. And we basically create a signal out of the big store, right? We create a signal out of a store count. And then we work with that. So we cannot pass the signal without revealing the data, like revealing the value of it. And by doing that, we can keep the signal unchanged up to the text node, which is the one that reads it by the first time. And then we can keep the subscription like that. But the nice thing about this is that even if you have, you might say, why I'm doing something that complicated? I could actually do this, right? I could actually do wrap signal here and just like, the problem is that in Qwik, we also have light components, right? And the light components.
Oh yeah, it's very different.
The light components.
Mano, you can mute as the admin.
Huh.
You can format their hard drive as well.
So the problem in Qwik is that you could have foo, right? And foo is just props, right? So if the optimizer is local, like the optimizer cannot use type information, or it needs to be able to tell and do a transformation only by looking at the syntax. Because the moment you get into a transformation that depends on types, it's impossible, right? It becomes like extremely complicated and error prone. So the transformation needs to be local. It needs to be like, by looking at this code, I can perfectly make something. I don't need to know where the value comes from. The problem is that if now I do, for example, count, right? I do props.count and I do type of equal number, right? If I do that, right? If I do wrap count here, wrap signal, then I will be breaking this. Now in the other side is not really a number. Does it make sense?
Mm-hmm.
In the component, we can do the tricks because remember, it's a proxy. So in the proxy, we can do all the magic we want, right? In the proxy, we can read the signal or, do all these things. But in the light components, you are literally getting the props, right? So you don't want to mess with that. It will be like a bad thing. And again, we cannot be looking like, oh, foo a component or it's a light component, because that's where the optimizer will start to do stupid things, right? Like we cannot, because then we will have to go to the file, check the implementation, then another of the problems that the Svelte has, because Svelte goes to that level. Svelte is not context free, right? Svelte is context aware, and they need to know where the things comes from. One of the problems that Svelte has is that you cannot have composability. Like in Qwik, you can create your own, use my own state that internally calls use store or whatever, and it will work. You can create your own utils like in React, but in Svelte you cannot, because the optimizer needs to know it all, right? And then composability doesn't work. So that's also a trade-off that we have to make in the optimizer. You have any more questions, please? Otherwise, I don't know how many people.
Everything is amazing. Yeah.
I'm happy you like it. It's going to be, I think it's recorded. I hopefully didn't mess it up and stop recording.
Yeah.
Let's see. Yeah, it's recording, so this will be all good.
Manu, this was an amazing session. Thank you so much for investing the time and showing us all that. I'm sure it will be very valuable for like adding more contributors to the project and less question.
Hopefully, even if you don't, like, it was some inspiration of how it works actually. Just don't copy Qwik and make something else. Just contribute to Qwik. We are still.
Oh, damn it! Now I need to do what I did.
All right, guys. If not,
Thanks.
I'm going to have some dinner.
All right. Thank you so much.
Thank you very much for coming.
Thank you. Bye bye.